Good afternoon, ladies and gentlemen. First of all, I wish to thank the committee of the IHTC 16 for inviting me to give this talk about non-Fourier heat conduction and optimization of irreversible thermodynamics approach. The content of my talk is such. First of all, an introduction about Fourier and Onsager laws. It's a very old story beginning in the 19th century with the Fourier laws and in the 20th century in 1931 with Onsager laws. The laws of Fourier are empirical laws, linear laws between what we call fluxes and forces in irreversible thermodynamics, while Onsager started from a more philosophical principle, that is, that causes are related to their effects also by the most intuitive law that exists, that is the linear law of cause. After that, I will talk a little bit about optimization principles and variational methods, then stationary and transient states stability, and with the methods of the classical and the extended irreversible thermodynamics applied mainly to transport phenomena, because our concern is here heat transfer. And then I will also introduce a very important new concept introduced by Guo, the least entropy principle. Now, introduction of the Fourier and Onsager laws. Due to the linear laws introduced both by Fourier and Onsager laws, the entropy production is a bilinear function of forces and fluxes, and that gives it a minimum property that describes the regression of the fluctuation for only those linear laws. And the Lagrangian principle is then for that system the minimum of the entropy production. When the coefficients are no more constants, when the laws are no more linear, of course the problem is quite different to rule the regression of the fluctuations and to show how the system reach the best way of functioning, that is the most probable state. And to describe this property of vanishing the fluctuations around the most probable state, first Glanzdorf in 1965 and Glanzdorf and Prigogine in 1971 have introduced a new property that reaches a minimum when the fluctuations regress. This is the excess entropy production given by half the derivative in time of the second derivative of entropy, which comes also with an Einstein principle of regression of the fluctuations. And they describe then a new Lagrangian formulation with a Lagrangian functional that depends both on fluctuating temperature and its difference with the most probable temperature that is realized after the regression of the fluctuation. And this quantity is given by the product of the Fourier coefficient multiplied by the square temperature, most probable temperature, and by the squared gradient of the difference of the reverse temperature fluctuating and minus the reverse steady state temperature, both quantity integrated on the whole volume of the system. This Lagrangian functional is quite similar to the entropy dissipation function described by Guo and co-worker. Both properties, both functions, the functional given by the excess entropy production and the so-called local potential of Glanzdorf and Prigogine, and the entropy production in the linear system, both functions reach a minimum, but not the same minimum. The minimum of the entropy production is quite different as the minimum of the local potential given by the excess entropy production. You see that both minimum are quite different, and they even in far from equilibrium system, very nonlinear and unstable system, then you see that in this case of unstable system, the entropy production reaches a maximum, while the excess entropy production, it is the local potential, reaches always a minimum. Thus, the local potential always can be used for characterizing the optimization of the system, the way this fluctuation regress to go to the most probable state. The potential described by Guo for optimizing his system, it is the least entropy production principle, has the same mathematical properties as the local potential developed by Glanzdorf and Prigogine. It is thus a very useful tool for optimizing heat transfer. And peculiarly, the Guo principle is perhaps more applicable for engineers because it is more linked directly with experiments. Now, the variational principle developed by Prigogine, which are quite similar to the principle developed by Guo and his team, are both valid for transient and steady states. I recall that the absolute minimum developed by this function, Lagrangian functional, which is half the integral over the all volumes of this quantity. There is a link, of course, between the Guo principle and the classical and extended irreversible thermodynamics. True, for instance, the entropy production, and especially with the irreversible thermodynamics, it can be shown that when choosing as force an extended forces that includes the variation in time of the heat flux, a comparison is possible together with the law of Guo and its most important principle, now developed recently, the thermomass principle, equivalence principle. This last principles takes as a starting point the law of equivalence of each quantity of energy and a mass, and especially the quantity of heat stored in a system can be attributed to an equivalent mass that moves with a velocity u and undergoes friction forces. In such a way, a new dissipation function, a product of the friction force by the velocity of this thermomass, can be described and gives rise to a new formulation of the entropy production that is very, very innovative and useful for use in the heat transfer processes, and especially in the micro and nano systems. By identification of the both forms of the minimum entropy production principle developed by extended thermodynamics and the Guo thermomass principle, one can give an expression very useful of the velocity of the thermomass linked to the quantity of heat exchange, the heat capacity and the temperature, and giving also the expression of the friction force. It's very easy now to handle those expressions, and it's a very innovative system, and I invited you to read the new publications developed by Guo and his team in 2013 and in 2018, and these two publications are very of the most importance, and I thank you for your attention.